Hello and welcome to this presentation on DirectX11 model loading. Some of you have brought this up in the discussions. One nice feature to have would be able to load up a model that's been exported from some art package like 3D Studio Max or Blender or something like that. It turns out there's a variety of different model formats. One somewhat simple one that we're going to look at today is referred to as the wavefront object file format. If we go to the Wikipedia site on the file format, it'll give you the definitions of the contents of the file. So the wavefront object file is just a text file, and any line in the file that begins with a pound sign is a comment, and any line that begins with a V is vertex data, either XYZ or maybe XYZW in this case. Any line that begins with a VT is a vertex texture information. VN is vertex normal information. And then faces begin with an F, and then these numbers after the F are indices into either vertex, texture, or normal data. So for example, this face is made up of 3 indices into vertex data. One potential issue is that we have to account for is that the face indices here are 1 based instead of 0 based. So every index we're going to have to subtract 1 from so that it starts with 0. So in the example over here we can see that we have a cube. It looks like it's been exported from Blender. And the first vertex is -1, -1, 1, -1, 1, 1. So you've probably seen data similar to this before. There are vertex normals. Unfortunately, this particular export does not include any texture data. So the sample code that I'm going to give you uses a vertex format that just has position and texture, but this particular model doesn't have any textures on it, so you'll have to add that or make a change to the code so that it renders using normals and lighting. If we look at the face data, we see that we've got something odd here: 2//1, 3//1, 1//1. What that means is that the first number is the index to the vertex data. The second number that's missing in between these 2 slashes would be the index to the vertex texture, but it's missing because we don't have texture coordinates. And then the third one is the index to the vertex normal, and we're not going to use the vertex normal in this case. Something else to keep in mind is that the code that I'm going to share with you, I believe it only supports triangles and not quads. So in some cases, when you export to object file, it may actually export faces with 4 vertices to define a quad, and I don't believe the software that I'm going to share with you supports that. So when you do the export, make sure that you select the option to export triangles only. So for example, this 2 has to be converted to a 0 based index, so we subtract 1 from it. So the index here is really 1, and I go up here to 0, 1. So this face is made up of, this first vertex is this one here. The second vertex is a 3. We subtract 1 and get 2. We go 0, 1, 2, so it's this one. And then the third vertex is a 1. We subtract 1, we get 0, so that's the first one here in the list. Remember, our lists in arrays and vectors are zero-based, so we have to subtract 1 from this data. The texture information, like I said, isn't there, so we'll have to make up some dummy texture data in the code, and then the normals indices are a little bit, can be different. They don't have to be the same. We have a different list of normals than we do vertices. The parsing of complicated text files like this could be pretty challenging, so I'm going to share the code with you that does this. I've had for a while for other uses. Again, the face index data is one-off, so we have to convert from one-based to zero-based indices. And then let's take a look at the code that we've added to the polyObject class. In the header file, we've added some functions. One is called parse face data, one is called find faces, one is called compute face normals. So the parse face data takes a vector of indices and a string and goes through this string looking for slashes or double slash, and if it finds one, it computes the particular, depending on whether it finds a double slash or has a certain number of slashes, then the vertex type in the face data is either vertex normal indices or just vertex or vertex texture or vertex texture normal. So this code will handle a variety of formats, maybe not all wavefront object formats, but it will handle a variety of formats that include vertex texture and normal data, but for triangles only. The find faces takes this face list and face list indexes and goes through and tries to find a list of faces and pushes them back in this face list data. The compute normals function is what it sounds like. It takes this face list data and the vertex data and will actually compute the normals using cross product and normalize out of the DirectX toolkit. So here we've included another header file from the DirectX toolkit called simplemath.h, and this will get us access to a function to compute the face normals, the cross product and the normalization functions to help us compute the face normals. Another thing that we added to the polyObject module is this enumerated type for the wavefront vertex type. So remember that the vertex in the exported model file can have just vertex information or vertex texture information or vertex texture and normals or just vertex and normals. So it'll handle exported models that have some data, not others. We've also added lists of vertices, list of normals, and list of texture coordinates, as well as a list of face indices. And remember that some of those might be missing, so the texture may not be there, the normal may not be there, depending on the vertex type. And we've also added two functions here. One is load from an object file, so you pass in a string, and this is a ASCII string, not a Unicode string, so keep that in mind. And then copy the data to the vertex buffer. So this load parses the text file and fills in these lists. And then what we need to do is copy the data according to the face index data, copy it into the vertex buffer and the index buffer, and that's what this function does. So we'll take a look at just a little bit of this loading and parsing function. And it calls another function called getContents from file. And so for performance reasons, instead of reading, say, a line at a time from the file, we're actually going to read in the whole thing. So we read the whole thing into memory, into this big string buffer, and then we start parsing it. And we're looking for particular markers, and in particular we're looking for anything that begins with a V or an F or a pound sign, and everything else we'll just ignore. So if we're assuming that the buffer position is at the beginning of the line, and so if the beginning of the line begins with a V and then the next character is a T, it must be texture data, so we'll parse this texture data. If it's VN, then we'll parse this normal data. If it's V in a space, then we'll parse it as vertex data. If it's F in a space, we'll parse it as face index data. And if it's a pound sign, it's just a comment, and we'll ignore it. There's some additional code to try to handle lack of texture data, and if there's no normals, we'll go through and find and compute them. And then this is the code that copies the data to the vertex buffer. So we grab the vertex index list from a face, and we loop through each vertex in that vertex index list. So notice here's where the limitation is on three vertices for each face, so it has to be triangle data. We grab out the vertex index, the texture index, the normal index from the face index list data. And in some cases, the texture index or the normal index might be negative if they didn't exist or there wasn't any. So we make up some index. And then once we get the vertex list, once we get the particular vertex index, we push that and the texture index, the texture coordinate, we push both the position and the texture coordinate into this, our vertex buffer, our vertex position texture list. And the index list is just the face index that we're on. So we have a loop where F goes from 0 to number of faces. So it's the face times 3 plus the vertex that we're working on. So we can just compute the index list just like that. So it's quite a bit of code, but fortunately it's been done for you, so you can just use it, and maybe if you're interested in modifying it to support additional features like maybe quads, you're welcome to do that. From a high-level view, how do you actually use this? It's very similar to how we've been using the poly object before, with maybe one or two additional steps. In our application, we've defined here a box and a torus, and they should be poly objects, not terrain. And then when we go to initialize the geometry, just like we've created other things like the pyramid, we initialize the box and the torus, but instead of calling one of the create functions, we call two functions. One is the load from the object file, and I put the object file in the media folder, and then the other function is copy the data to the vertex buffer. So this loads and parses it, and then this copies it to the particular vertex buffer using the vertex type that we have. This is something similar for a torus. We have a torus object. When we render, it's really the same as what we've seen before. I've commented out the pyramid so we won't see that. We get the world view and projection matrix from, in this case, the box and the camera, and then we set the constant data, and then we render the box. And we do the same thing here for a torus. Here is Blender, and I have a torus here I've created in the middle. And to export it, we go to File, Export, and we choose the appropriate type. In this case, it's the wavefront object type. And then we choose a location. Again, I'm putting it in the media folder of my project. And also we go down here for export options, and we make sure that we select this triangulate faces so that all the faces are triangles. So that's an important step. When we do that, when we do that export, then we'll end up with this box object, and Windows is putting an icon on this that's related to programming files. So the .obj extension is also used as the result of a compiled C or C++ module. So it's using an icon for that, and if you just try to double click on it, it's likely going to try to open it in Visual Studio somehow. I'm not sure exactly what that would do. But if we just make a copy of it and rename it to text, then we can look at it in Notepad or Visual Studio, and you can see that there's the data that's in the box object file. Something similar for the torus. So if we can build and run this, you can see that we've got a torus and a box here. Now notice that they don't look particularly great because, like I said, there were no texture coordinates. So you'll have to export, you'll have to create a model that's texture mapped, or find a model that already has texture coordinates in it and use that if you want to make something that looks better. So again, be sure that when you do the export that we export triangles, as I don't think the current code supports quads. So that concludes this presentation on DirectX11 model loading. Let me know if you have any questions.